Good morning and welcome everyone for this course Physics 1, which is generally made for first year of B.Tech Degree students. Myself Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baruipur. You can contact me at college premises in the ground floor physics lab, or personally you can mail me your doubt or any reason regarding this course or any problem solving regarding your syllabus at godphysics6@gmail.com or gopal.chakraborty_gkcem@jsgroup.org. I have already uploaded lots of YouTube video in my YouTube channel. You can subscribe my channel to clear your doubt. So I am the subject teacher for this course Physics 1. You can find the course page at www.makautexam.net or www.makautwb.ac.in. You can also find the syllabus is uploaded there. The title of the course is Physics 1. The subject code is BSPH101. The category is under Basic Science course. It has a credit 4 and the 3 lecture per week and 1 tutorial per week. The course is generally made for first year B.Tech degree students. So for the odd semester, computer science, civil and mechanical, these departmental students will going to study this course, and in case of EC electrical department, they will study the same course in the event semester. Today I am going to solve some numerical problems on vector calculus, which is under module 1 mechanics. The prerequisite for this tutorial is fundamental of mathematics and elementary idea of vector calculus. The course objective is to present the fundamental concepts of vector calculus and to develop student understanding and skill in the topic necessary for its application to science and engineering. The corresponding course outcome are compute dot product, cross product, vector, differential operator, Gauss divergence theorem, Stokes theorem, etc. Students can also able to derive different types of partial derivatives, derivatives of vector valued function, gradient function, etc. Also they can use the Gauss divergence theorem and Stokes theorem to compute different types of integral. So before start solving some numericals on vector calculus, I want to remember you the details that we have already discussed in our last 2 video tutorials on vector calculus. Okay, so in first chapter, in first tutorial, I have already teach you regarding the vector, different types of vector, okay, and the dot product and cross product, which is very important to solve the numericals. Okay, so the different types of vector, there we have discussed what is unit vector, what is proper vector, what is null vector, what is coplanar vector, axial vector, etc. So here the main requisite is what is unit vector, that has lots of application when you are going to solve some numerical. Okay, unit vector, you remember that the magnitude is unity but it has a direction, and how you will find out the unit vector? Unit vector means that vector divided by mod of that vector. Okay, and how you calculate the modulus? It is root over ax square plus ay square plus az square. If you denote the vector a with a bar or hat is equals to ax I cap plus ay j cap plus az k cap, where I, j, k are the orthogonal set of unit vector. Okay, fine. And the dot product and cross product. So dot product is a dot b equals to ab cos theta, okay, where a and b are the magnitude. And to find out the dot product, I have already discussed in details in my last video, so here I will not discuss the same thing again. Okay, I will only solve some numerical over the dot product and cross product. And cross product is a cross b equals to ab sin theta with the n cap. So the basic thing is scalar dot product will give you a scalar quantity, whereas the cross product will give you vector quantity. Okay, so it will give you a new vector which is perpendicular to the plane made by the two vector. Okay, so these are the vector dot product and cross product. That thing you have to remember. And another thing you have to remember that in last second video of vector calculus I have already discussed regarding the vector differential operator, which is very important. So this is basically a three-dimensional operator, okay, which has a value del x I cap plus del y j cap plus del z k cap. Okay, so if you want to calculate this gradient operator or divergence operator or curl operator by this vector differential operator, it will depend how this vector differential operator will operate over the quantity, given quantity. So if the given quantity is a scalar one, so the vector differential operator, if operate over that scalar quantity, it will change the scalar value to a vector one, okay, and then that will be called gradient operator. When this vector differential operator will operate over some vector quantity with dot product, then it will be called divergence operator. Okay, the procedure is as simple as you are calculating the dot product. Okay, and the last one is the curl of a vector with a vector differential operator. Then it will be called, that means you are operating this vector differential operator over some vector quantity with a cross product, then it will be called curl operator or operator. Okay, so these are the basic three uses of vector differential operator. And I have also discussed which the very important formulas. Two theorem is there. One is Gauss divergence theorem, another one is Stokes theorem. So Gauss divergence theorem basically relates the surface integral with the volume integral, and Stokes theorem basically relates the line integral with the surface integral. So you remember that all these integral must be a closed type. Okay, so it's a closed circle or closed surface or closed volume. Okay, so I have already discussed in details in my last two videos on vector calculus. So now we are going to solve some numerical over this all the vector calculus chapter. Okay, so remember one thing, that you need to understand what is the procedure to solve that kind of a problem. You don't need to remember each and every problem separately. You need to understand the solving procedure, the techniques you need to apply to solve the same type of problem. Okay, if you understand this, then it will be very clear to you how you will deal with that kind of a problem. Okay, so to solve this problem, I have already shown you some formula is given there. So you have to apply some formula, or you have to apply somewhere some physics is needed. That means your conceptual thing is also needed to apply there to solve some problem. Okay, so first of all I will show you all the formula you needed to solve this kind of a problem. Then I will solve one by one different type of problem regarding this vector calculus chapter. So the formula is there. You can see lots of formula is there, okay, on the chapter vector calculus. But I have written here only 18 formulas, 17 or 18 formulas, which is very important to solve the numerical on this basics of the vector chapter. Okay, if you find out the books, okay, you find at least 100 to 200 formula is there. Okay, but for the B.Tech first year degree course, you don't need to remember all these formula. So this formula is almost sufficient to solve the numericals. Okay, so first one is A dot B is equals to B dot A. That means the dot product will be similar, will give you the similar value if you alternate the vector. But in case of cross product, it is not equal. Okay. Third one, it's a positional vector. The value is R equals to xi cap plus yj cap plus zk cap. Fourth, R dot R will give you R square. So from there you can easily find out the magnitude of the positional vector, which will be R equals to under root x square plus y square plus z square. Formula 5, it's a vector triple product formula. Vector 6, it is also vector triple product formula, that A cross B cross C is equals to B A dot C minus C A dot B. 7th, it's a dot B cross C is equals to B dot C cross A equals to C dot A cross B. Okay, now last 8 and 9, that's the dot product and cross product. I have already discussed this. Okay, next 10, that is the value of vector differential operator. It's a 3-dimensional operator. Okay, so del square, that means grad square, which is a Laplacian operator, that is equals to del 2 del x2 plus del 2 del y2 plus del 2 del z2. Okay, 14, it's del r to the power n, that is equals to n r to the power n minus 2 dot r. Okay, I have already derived this formula in my second video on vector calculus. 15th, if del dot A, that is very important. Okay, how you will find out that whether the vector is solenoidal or not? If the divergence of that vector is equals to 0, so it must be a solenoidal one. And if the curl of this vector is 0, then it must be a irrotational or conservative one. Okay, and last 17 and 18, there is a Gauss divergence theorem and Stokes theorem. So these are the basic 18 importance formula. We will solve lots of problems using this formula. So the first problem is here. You have to prove B cross C dot within second bracket and third bracket C cross A cross B is equals to right hand side A dot B cross C whole square. Okay, so this is the important one. Okay, how we will solve? We will start with the left hand side. So in left hand side, B cross C dot within second bracket C cross A cross B. So first we will apply the formula in the left hand side. So B cross C will remain same, and then you will get C cross A dot B whole into A minus C cross A dot A whole into B. Now, as C cross A dot A is equals to 0, because you can put the formula A dot B cross C equals to 0. Okay, so A dot B cross C, that means B dot C cross A or C dot A cross B. That will give you here A cross A. So A cross A will be always 0. That's why C cross A dot A is equals to 0. So we will find B cross C dot within second bracket B dot C cross A whole into A. Then we get B cross C dot A common. So we will get B cross C dot A, which makes it B cross C dot A whole square. So rearranging, we can prove A dot B cross C whole square, which is your right hand side. Okay. Now the second problem, that is A cross B plus C plus B cross C plus A plus C cross A plus B equals to 0. So for this kind of a problem, you have to always start with your left hand side, okay? Then you have to apply the formula. So here in left hand side, first you simply multiply, it's a cross product, A cross B plus A cross C plus B cross C plus B cross A plus C cross A plus C cross B. Now if you take common A cross B plus B cross A plus A cross C plus C cross A plus B cross C plus C cross A. So that means as you know, A cross B is not equal to B cross A, but that value is a negative one and the opposite similar one. So that's why they will cancel out each other. So from there you can get, from the first part it's 0, from the second part it's a 0, and third part it's a 0. So which makes it right hand side is equals to 0. Okay. Okay, now the next problem. So the problem is, if A cross B equals to C cross D and if A cross C equals to B cross D, then show that A minus D is parallel to B minus C. So for this kind of a problem, if the question is, you have to prove two vector is either parallel or perpendicular. That means if a two vector is parallel one, so you have to prove the cross product of these two vector will be equals to 0, because A cross, you know, A cross B equals to AB sin theta n cap. So if the two vector is parallel, then sin theta value will be 0 because the angle will be 0. So you have to use this formula, okay? The cross product will give you 0. So here we have applied the same thing. So we have to prove the A minus D cross B minus C equals to 0. So starting with the first line, that is A cross B minus of A cross C minus of D cross B minus of D cross C. Okay. Now the next, A cross B plus D cross C, that means we substitute the value, okay, minus A cross C plus D cross B, again we substitute the value, okay. So from there what we will get, A cross B minus C cross D minus within bracket A cross C minus B cross D, which is actually 0 because A cross B equals to C cross D and A cross C equals to B cross D, that is given value. So with starting from the our consideration that the cross product will be 0, we get that our result is 0. That means A minus D vector, that's parallel with the B minus C vector. Now the next problem, you have to prove A cross B cross C plus B cross C cross A plus C cross A cross B equals to 0. So to solve this kind of a problem, again we you have to start with the left hand side, okay, and you remember that formula A cross B cross C, that means B A dot C minus C A dot B. So that formula you have to use, okay. So substitute all the value for each part of the left hand side, that means A cross B cross C, that means B A dot C minus C A dot B. Second one, B cross C cross A, so C B dot A minus A B dot C, and the last one, C cross A cross B equals to A C dot B minus B C dot A. So if you substitute all these value, you will get the line that is given here. Now you know that A dot B is equals to B dot A, so you can simply cancel out all these things, okay, and that will give you 0. So it's proved. Now the next problem, that is very important. You have to prove that curl of a grad phi, that is equals to 0. So whereas phi is a scalar quantity. So here first of all you have to find out what is grad phi. Then you have to take the curl of this grad phi, okay. So grad phi means grad del vector differential operator, that is del x I cap, del y j cap plus del k cap. So if you operate this operator over phi, so you will get del phi del x I cap, del phi del y j cap plus del phi del z k cap, which is a u vector, okay. Now you have to take the curl over this vector. So curl means you have to find out the determinant, okay. I have shown you here. Okay, now the determinant is here. As per formula, we have substituted all the value. Now del y over del phi del z. So del phi del z will behave as a constant. Okay, if you take the derivative with respect to y, so that will give you 0. Similarly, when you take the derivative with respect to z over the del phi del y, again that will give you 0. So similarly, you can find that all the derivative here, that will give you 0. All the partial derivative value will be 0. So you find that curl of grad phi, that is equals to 0. So this is a very important one, okay, and you have to understand that part after taking the determination. So rearranging all the partial derivative will be cancel out each other, okay. So that will give you ultimately 0. Fine. Now the next problem, with the help of Gauss divergence theorem, show that volume of a sphere is pi d cube by 6, where d is the diameter of the sphere. Okay. So how we will solve this Gauss divergence theorem is the theorem which relates the surface integral to a volume integral. Okay. So here the formula is there. Surface integral r dot ds, that is equals to volume integral del dot r dv as per Gauss divergence theorem. Now, so r dot ds, that radius and the surface, these are the parallel with each other, so cos of angle will be 0. So you find r integration over ds, because cos 0 is 1. So in right hand side, del dot r, you know del dot r, that value is 3. We have already derived or discussed in my previous video, so that will give you 3 dv. So we find integration of 3 dv over the volume. Now r into s, because s is the total surface area after taking the integration over ds, equals to 3 into v, where v is the total volume after taking the integration over dv. So v equals to r into s by 3. Okay, so r is the radius, s is the surface area. So surface area of a sphere, that is 4 pi r square. Okay, we substitute all this value and that will give us that pi d cube by 6. Now the next problem, a force 4i cap minus 3j cap plus 2k cap passes through the point minus 9, 2, 1. Find the components of moment of the force about the reference axis. So to solve this kind of a problem, you are asked to find out the component of moment of a force. That means you are asked to find out the torque, magnitude of some torque along x, y and z axis. So the torque formula tau is equals to r cross f, as we know. So we have the f is already given there, so we have to first find out what is r. So r is the position point is given, so corresponding positional vector will be minus 9i cap plus 2j cap plus k cap. Okay, now we have to find out the cross product of these two vectors r cross f. The cross product will give you 7i cap plus 22j cap plus 19k cap after taking the determination. Okay, so this is our torque vector. Okay, so I cap has a component 7 along x axis, 22 j cap, so that means 22 is the component along y axis and 19 is the component along z axis. Okay, so these are the required answer. Next question, a particle moves on the curve x equals to 2t square, y equals to t cube minus 4t, sorry, it's a t square minus 4t, z equals to 3t minus 5, where t is the time. Find the components of velocity and acceleration at time t equals to 1 in the direction of I minus 3j plus 2k. So to solve this kind of a problem, first we have to find out the positional vector that is r equals to 2t square I cap plus t square minus 4t j cap plus 3t minus 5 k cap. Okay, so first we arrange the what is our positional vector, then we can easily find out what is our velocity vector. So velocity vector is nothing but the dr dt. Okay, so after calculating the velocity, that means taking the derivative with respect to time over the r vector, that will give us 4t I cap plus 2t minus 4j cap plus 3k cap. So similarly we can find out what is our acceleration. Acceleration is nothing but dv dt. Okay, that will give us 4i cap plus 2j cap plus 0. That means no component is along k cap. Okay, now as per question we have to find out the component of v along the given vector I minus 3j plus 2k, and then the component of acceleration along the same vector. So how we will find out the component? The procedure is you are asked to find out some component along some direction of a given vector. So first find out the unit vector along the direction of that given vector. Okay, unit vector means that vector by mod of that vector. Then you find out the dot product of that unit vector with the velocity and with the acceleration. That will give you the direction of the component of velocity vector along that direction of the given vector, and also the acceleration component of acceleration along the direction of that same vector. Okay, so you understand the procedure. First find out the unit vector along the given direction vector, then you have to take the dot product with that vector. Okay, now another important one, if the vector a and b be irrotational, then show that a cross b is solenoidal. Okay, so a vector to be solenoidal, the formula is divergence of that vector will be equals to 0. So del dot a cross b is equals to 0. That things we have to prove. Okay, and the given one a and b are irrotational, that means as per given condition del cross a is 0 and del cross b is equals to 0. Now substitute all that value, del dot a cross b, that means b dot del cross a minus a dot del cross b. So if you substitute, we will get 0. So which proves that divergence of a cross b is 0. That means a cross b is a solenoidal one. Next one, determine the constant value a so that the given vector is a solenoidal one. Again the same type of problem. Okay, that means when a vector is solenoidal, divergence of that vector is equals to 0. So first we find out the left hand side value. Left hand side, that means dot product del dot v. Okay, the value we get here a plus 2. So a plus 2 must be equal to 0 as per given condition. So from there we can find out a is equals to minus of 2. Now the next problem, calculate the amount of work done in moving a particle in a force field given by f equals to 3xy I cap minus 4zj cap plus 8y k cap along a given curve. Okay, so you know what is your work done? It is f dot dr. Okay, f dot dr, that is the work done. So f is already given here, so you have to find out what is your dr. As you know that r is a positional vector, r is equals to xi cap plus yj cap plus zk cap. So that means your dr will be dxi cap plus dyj cap plus dzk cap. So first of all find out the dot product, and to find out the total work done you have to find out the integration of the given curve. So that means here the x value is given, y value is given, z value is given. So you have to substitute one by one all the x, y and z, and also the dx, dy and dz in terms of t and dt. Okay, then you have to take the integration with the given limit of the t. So to solve the first part, as I have discussed that f dot dr value you give you 3xy dx minus 4z dy plus 8y dz. Okay, fourth line of this equation. Now in the fifth line we have substituted the value of x as well as dx, y and z as well as dy and dz. Okay, so you can simply find out x equals to t square plus 1. So your dx value is equals to 2t dt. Okay, plus 1, that value will be equals to 0. So similarly we have substituted all these value and we find out the limit of t, that is given here already, t equals to 0 to 1. We are taking the integration over dt. Okay, that is from lower limit is from 0 and upper limit is 1. Okay, that ultimately calculating we get 57 by 10 unit. Okay, that is our result, work done. So work done is a scalar quantity, so here also we have find out that dot product f dot dr that give us that scalar value, that is a work done. Okay, so these are the reference book that I have already discussed in my last 2 video. Okay, so you can practice, lots of problem is given there. Okay, and if you find any doubt, you can mail me, as my given mail ID is already there. Okay, the evaluation process is almost same as I have discussed in my last 2 classes. Internal will be for 30 marks, external will be for 70 marks. Okay, so thank you. Hopefully all of you have understand my video here, that which discuss all the numericals related to the vector calculus. So I have completed this topic, vector calculus, with this video. Okay, so okay, lots of doubt may be there. Okay, because so many problems are there from the vector calculus. Okay, you practice, okay, from the book, or you can also contact me regarding the solving of this problem. I will certainly try to help you. Okay, in next class I am going to discuss the vibration chapter, which will be from the same module of your mechanics 1. Thank you.